Students, you are given a reaction containing a ketone and reacted with peracid. This peracid is an oxidizing agent. We have different types of oxidizing agent, a strong oxidizing agent like potassium permanganate, or a mild oxidizing agent like PCC, pyridinium chlorochromate, and we are aware of all these different types of oxidizing agent, and we are given yet another oxidizing agent like peracid. And what happens when peracid reacts with a compound containing an aldehyde or a ketone? This is a characteristic of an aldehyde or a ketone only, and not the other compounds containing C double bond O, because acids also contain C double bond O, esters also. Only aldehydes and ketones react with peracids, and you get different products. And you are given 4 options here, and the correct answer is written by writing the mechanism. Now, aldehydes and ketones react with peracids or CO2OH. This extra oxygen is added on to the carbonyl carbon atom either on the right hand side or on the left hand side. Now, this could be like this O, and depending on the nature of the alkyl group, or let me have different alkyl groups R and R dash here. So, if R is here, it could be R dash here. And this is an ester, and ester, of course, you have different esters. If oxygen is added on the left hand side, it becomes C double bond O R dash. They are different esters, and they are called metamers. Now, let us see the product after the rearrangement. Let me write C6H5 as the phenyl, C double bond O, and this is a methyl here, methyl, CH3 as a methyl. Now, I add CH3, CO2, O minus. Assume that this is going to be dissociated into anion plus H plus ion, and this anion peracid acts as the nucleophile. This peracid acts as a nucleophile, and what should happen here? The valency is disturbed, so naturally the oxygen is going to take away the pi electron, and what should happen? Look at the arrow mark. You have O minus, and this is Me here, and this is O. This is O2, C, CH3. Now, the whole thing should start from here. What should you do? I want to take away this oxygen, negative charge as a double bond, and one of these two groups is going to be attached to oxygen. Of these two, phenyl group has got a greater migratory aptitude than the methyl. That means it is able to migrate faster. So, the phenyl group gets attached here, and the whole thing comes out, as the leaving group here. The whole thing comes out. What comes out? CH3, COO minus. Now, look at the arrow mark and see, write the product here. It should be pH now, phenyl group is attached to oxygen, isn't it? Phenyl group is attached to oxygen, and as usual, you put the C double bond O, and methyl is intact. My dear students, you see here, methyl is, nothing happens to the methyl, it's only the phenyl group that migrates. And what is the leaving group? Leaving group is CH3, COO minus. And what is this product? This product is nothing but CH3, COO, C6, H5. And my dear students, most of the examination, they don't give you the structure, they give you the IUPAC name. So, you should know the IUPAC name of the compound. This is ethanoate, and this is phenyl ethanoate. So, the name of this compound can be called as phenyl ethanoate. So, this involves rearrangement, insertion of oxygen. This is called insertion of oxygen because the extra oxygen is inserted. And my dear students, it happens only in the case of an aldehyde and a ketone. If in the case of an aldehyde, maybe I can give you one more information. I have C double bond O and H here. Always the oxygen is inserted between the carbon and hydrogen. And this is an oxidizing agent. Now, you don't need to know the mechanism. You see here, where have you introduced the inserted oxygen? Between this and this. We know pretty well that aldehydes are easily oxidized to carboxylic acid, and in fact, this can be explained by the Baeyer-Villiger oxidation. This is an example of Baeyer-Villiger oxidation.